let's go ahead here and graph a system of two inequalities. A lot of times you're going to see these and they're going to be two lines, but I wanted to make sure to show you an example that had an absolute value so we could review how to graph that. You'll notice this first equation has the absolute value bars here. That should tell you something immediately about the shape of the graph. This one is not going to be a straight line. This one is going to be a V-shaped graph. Okay, remember V for value. So we need two things about this when we're going to set it up. We need to know the stretch factor, which is A, and we need to know the vertex, which comes from H and K. On this one, our A value, remember that's what's in front of the absolute value bars, so our A value is -2. And we want to treat that like a slope. So if it doesn't have a denominator, we put it over 1. Now the vertex comes from H and K. Remember the formula is X minus H. That means the opposite of H. So we have to flip the sign here when we pull out that number. So the vertex is actually going to be -1, and then the K you keep exactly the same, +2. Just kidding, that should be a -2. Right here. This is where the K comes from, and because it's subtraction, we're going to make it negative. Remember, K is the one that you keep, so you will not change the sign on that one. Something else that you should notice about this inequality is that it is not equal to, it's just a greater than. This means that our line is going to be a dotted line. Don't draw a solid line there. Okay. So let's go ahead and put this on our graph then. We're going to have to shade on this graph. The way we know that we're going to do shading is because there's inequalities. There's greater thans and less thans. If it's just an equal sign, you won't do any shading. Just graph the lines and see where they cross. But these we're going to have to do some shading. So our vertex is going to be at -1, -2, which is going to be right here. Notice the graph is counting by 2's. And then our stretch factor is -2 over 1. That means we're going to go down 2 and over 1. But remember, with absolute value, every point that you graph, you have to reflect it back the other way as well. So again, down 2 over 1 here, reflect it back this way. So you can see our V kind of coming to shape here. Dotted line, because it's not equal to. And now we have to decide where to put our shading. This is a greater than, which means I have to shade above the graph. And a lot of people are getting confused as to where above or below would be. Well, above would be this direction. Below would be this direction. Don't think of it as an inside and an outside, okay? It's going to be above or below. And so let's get this highlighter off of here. Okay, pretend that's not there anymore. So this is greater than, which means we're going to shade above. And remember I showed you in class, I like to shade when I have to do overlapping like this. I like to just shade with lines. And I'll show you why here in just a second. Now we're going to go ahead and graph our line. That's going to be, let me switch colors. That's going to be this second equation. We know that that one's going to be a line because it's an x to the first power and there's no absolute value bars there. So what we have right now is x minus 3y is less than 15. This is not ready to graph yet because it's not in slope-intercept form. So we got to do a little bit of work. We'll start by subtracting x from both sides. That leaves me with -3y is less than -x plus 15. Then we need to divide, and again, we keep talking about this, we have to divide everything by -3, not just the x term, not just the constant term, we have to divide all three parts. Also remember that whenever you divide by a negative, you have to switch the direction of your inequality. So mine's going to, instead of being less than, it's now going to become greater than. So I have y is greater than. Now I have negative x over negative 3. And because a negative divided by a negative is a positive, this gives us a positive 1/3 x. Don't leave it as negative 1 over negative 3. That's just bad grammar, basically. And then positive 15 divided by negative 3 is negative 5. This is a line, and it's now in slope-intercept form, so we can go ahead and figure out our slope and our y-intercept. Remember, the slope is the number in front of x. X is not part of the slope. X has its own job. So m is 1/3, and b is this number, and because we see subtraction there, that means it's a negative 5. So when I graph this, let me switch back to pink so we can see it. When I graph this, I'm going to start with my point on my line at negative 5. Remember that B represents the y-intercept. You need to learn that vocabulary because that's what's going to help you remember to put it on the y-axis. So that would be right here. My slope is 3, so that means I'm going to go up 1 and to the right 3. Up 1 and to the right 3. This one is also going to be a dotted line. So we'll go like this. And with lines, it can get a little tricky, so we need to test a point. Let's plug in 0, 0 because it's not on the line. So when I do that, I get 0 is greater than 1/3 times 0 minus 5. In the end, that's going to say 0 is greater than negative 5. Is that true or false? That is true. 0 is bigger than negative 5. That means that this point right here, 0, 0, is a true point. And we want to shade the points that are true. So that means that from this line, we're going to shade this direction. You'll notice that I chose to use lines that are going a different direction than the red ones. That's because you can clearly see everywhere that my lines overlap, like this, that's where my double shaded area is. And on these graphs, you then have to darken in the area where they overlap. Inside of this V here, nothing overlaps. And below the dotted line, nothing overlaps. But it's going to be everything out in this region that overlaps. That is where my double shaded area is going to be. And so that's where we could find our solutions. Now, we could just as easily have done a system of 3 inequalities. If that was the case, we would just graph a third line and we'd be looking for the triple shaded region. Any point that is in this double shaded area is going to be a solution. I could pick this point right here, 2, 2. That is a solution. This point over here, negative 3, 1. Negative 3, negative 1. That is a solution. If I were to pick anything outside of that purple area, it would not be a solution. So that's just a quick snapshot of graphing inequalities.